Welcome. This is an overview of the syllabus for your engineering and design course. I'm actually recording this on 8/24, so the last revision of this was actually today. So occasionally I'm going to have to revise this during the course, like tweaks here and there because of just how things run. Um, if there's ever going to be a change to this, I will announce it in three ways. You will get an announcement during class. You will see an email about it, and this syllabus will always be hosted in the same location in the Schoology. So a revised and current version of the syllabus can always be found on Schoology. All right, so this document is basically the living document that is the rules of the road for this course, for what this course is about and how we're going to manage it. Quick overview of the course. This is designed to bring you to the principles of the engineering and design process. It's going to be a project-based learning approach. So you're going to do a series of 5 projects over the year. We're going to use those projects to learn about the engineering and design process and some of the tools that engineers and designers use to solve problems in our world. You're going to develop both skills and techniques, as well as ways to think critically about the designed world. This is a course that is designed to be the nexus of the STEAM fields, so we're hoping to engage and use the functionalities of science, technology, engineering, three-dimensional art, and mathematics. All right, so the course meets during E-Block. We're going to talk a little bit about where it meets. From time to time, the location of class is going to be different. We're going to have 2 homes. One will be the three-dimensional lab down in the art building. The other will be at the new Marshall Offutt room 201, which is my mathematics classroom. The reason for this is that there's an engineering piece to this class and there's a design piece. And the engineering piece is going to have some serious instructional components, which is they're best done if we're in a regular classroom setting. And then the design piece, where we're actually doing construction and building models and things like this, are probably best done in a three-dimensional lab. I'm going to use the calendar on the Schoology page to let you know where we are each day. I will do my best to communicate also via email and in the classroom, making sure you are in the correct place each day. So there is like a lecture space, quote unquote. I'll call it an instructional space and a lab space for this class, and depending on the day, we'll be in one of those 2 spaces. So we're always meeting during E-Block. We're not always meeting in the same place, and I will help you the best I can keep track of where you need to be each day. I am Beam, that's my name. My free periods are BDNG. So I can be found during those times, usually before school and after school as well. My preferred mode of communication is email. So if you are trying to catch me, the best way to get a hold of me is via email. I tend to respond quickly to that. I will also be operating off the assumption that you are checking your email. This is a hill I'm going to die on. All right. So each day, make sure you're checking your email. It's going to make it easier for me and for you if you're doing that, so that we can keep on top of communications. All right, so here are the objectives of the course. We're basically using the design process to solve real-world problems. We're going to look at the relationship between engineering technology and design. We're going to make some 2- and 3-dimensional models of real-world objects in order to engage in design without needing to fully construct a prototype. We're going to articulate how power and electricity can be used in finding solutions to the real-world problems. We're also going to store potential energy and harness it to generate motion. And then we're going to work on a large-scale project and bring it to completion under budget and on time. All right, there is a textbook for this class. Engineering the Future, Science, Technology, and the Design Process. You do not need to bring this book to class every day. There will be readings from this. Don't blow off those readings. They are important. They'll be on assessments, so be aware of that. Okay. You do need a TI-84 calculator. You need it for your math classes anyway, but the assumption is that you're going to have that calculator and you're going to use it. You're going to need a pencil. You're going to need your laptop. Okay, these are all going to be important. A lot of the material that we're going to do in this class is going to get passed to you through Google folders, so make sure you have your laptop every day and it's charged and ready to go. The course only has 4 units. The first 2 are in the first semester. It's basically 1 unit per quarter, give or take a little bit. Unit 1 is the designed world. Unit 2 is modeling. Unit 3 is power and circuitry, and Unit 4 is motion. There will be also an ongoing year-long large-scale project, which is going to be about pond access, and we'll get into this. The 4 projects that we're working with here are a glider, which is our first project of the year, a wood block racer, which is the second project, building a dollhouse that's going to be powered and electrified and all that will be the third one, and a tennis ball launcher. So those are the 4 big projects throughout the year, and then the ongoing project will be about access to our pond for some of our younger students in the lower and middle school. So we're going to get into that as the class moves on. So how do you get a grade? Okay, so there are going to be bits and pieces. Each project will have its own grading scheme, which will be given to you at the beginning of that project. So there'll be a whole grading scheme that goes along with each of the components that goes along with the glider project, for the wood block project, for the dollhouse project, the tennis ball project, and the year-long project. Okay, so the way this is going to work is the glider project and the wood block racer project will constitute each 25% of your semester 1 grade. The work that you do on the year-long project there will count 15% of your semester 1 grade, and there'll be occasional announced formative assessments, which are basically quizzes, which will make up 15% of the semester 1 grade. The semester 1 exam is 20% of the grade. In semester 2, it's a similar scheme, but because there is not going to be an exam, each of the projects is slightly larger than they are in the semester 1. So since all of the students in this course are graduating seniors, there will be no second semester exam. Okay, so the final grade in this course will be the average of your first and second semester grades as outlined above. There is no extra credit in here, and because this is a project-based course, there's going to be plenty of opportunities for revision, but there's going to be a no retake policy. Okay, keep in mind that assessment of projects will be graded in such a way that the grade reflects your understanding of the content, your ability to persevere, think critically, work creatively, and work collaboratively, and to be curious. And these are things that, like, when I'm writing comments on the course, this is what I'm going to be writing to. Is these skills. Like, so please be aware that these are things that I'm looking for. Can you persevere? Can you think critically? Can you work creatively? Can you work collaboratively? Can you be curious? The work habits are the sliders on the report card. These are engagement. Are you there and are you present? Are you working actively? Are you paying attention to detail? Are you organized? Are you self-advocating? Like, if you don't understand something, are you ready to deal with that? And is your work getting done on time? These are things that will be dealt with in the sliders on the report card. The material here is just about straight from the student handbook, the attendance policy. Everybody has absences. We get that. If you're sick, talk to me on the day you get back. Let's figure out how we're going to deal with the makeup work. If you are coming in after an illness, you're supposed to have the work that was due the day before you got ill. If you have missed a quiz, you got to make it up either during a free period or possibly the evening study hall. That's open to both day and boarding students. If you need to, stay for dinner and, come to study hall and get something done. It's all good. If you're going to know in advance that you're going to miss, you need that, what do you call it? The planned absence form. You need those 2 academic days before the absence. Late to class is cutting class is 6 demerit offense. That's in the handbook. So if you're missing more than half the class, you're gonna see demerits. Hopefully this won't happen. I'd like it not to, but things being as they are, we need to have rules. If you're late to class, that's a demerit. I'm gonna be as gentle about that as I can, because I know that we're going to be changing spaces from time to time. And one day we might be in the lab and one day maybe in the room. Try your best to make sure that you're keeping up on where you need to be. Again, check your Schoology calendar. It will tell you, I need to be in this space. If you are more than 10 minutes late for class, that's a 2 demerit situation. And, it's just what it is. Academic honesty, your work should be your own. However, we do highly encourage collaboration here. If you're ever unsure whether or not the collaboration that you're doing is actually collaboration or if it's cheating, let me know and we'll talk about it and we'll see if we can make that work. But ultimately, I'm really excited about this year. I think this should be a fun and enriching course. It's got a little bit of a different feel because it's project-based rather than text and test based. I hope that you enjoy that. Trying to work out some pretty nifty field trips and some guest speakers and things like that throughout the year, so you're making connections with professionals in the engineering and design world and some end users. And that's it. If you ever have any questions about the syllabus or about the course, reach out. Again, remember that the preferred method of communication here is always email. All right. Thank you.